Hi everyone. In this session, we are going to look at some very important questions that can be seen in the selective year 8 exam or be it year 9 exam. So I would suggest that if you have anyway encountered this video, you just have a look at it and probably it will help you. So let's see the first question. It states that find the points of intersection of a parabola and a line. uh, we have been given two equations. As you can see, that first one is a quadratic equation and the second one is a line equation. And we are looking for such points which are common between the line and the parabola. So these 2 points, there can be 2 points. There could be just one point where the line intersects the parabola, and there could be a possibility where no point touches the parabola. So we are going to look at how many roots we are deriving from the quadratic equation, and that's how we will realize that where the line is cutting the parabola. Let's go ahead. You can see that there are same left hand side we are having. So we'll just equate the two right hand sides as well. 4 is equal to x square minus 3x. Have some rearrangements. So x square minus 3x minus 4 is equal to 0. Now we will factorize this quadratic equation. As you know, the method of factorization can be any, be it middle term split, quadratic equation, or completing the square method. You can choose any. We would first go for checking with the middle term split method. So we can see that the product of the roots should be x square times minus 4x square. So this is the product, that is minus 4x square. That should be the product of the roots. And the addition should be minus 3x. So a pair that I can form is x square minus 4x plus x and minus 4, because minus 4x times plus x is minus 4x square and minus 4x plus x is minus 3x. So probably this is how you can proceed. Now take common x and x minus 4 plus 1 common x minus 4 is equal to 0. From this term we can take x minus 4, and of course if you have to take common you have to check that in both the terms we have got x minus 4. So it was present in both of them and we are left with x plus 1. So this is how we have found the factors of the quadratic equation. The roots would be just equating x minus 4 to 0 and x plus 1 is equal to 0. So we got x is equal to 4, x is equal to minus 1. Put them into the quadratic equation to find the value of y. That would be 16 minus 3 times 4 is 12. We got another 0.4 and y is equal to x squared. So 1 minus 3 times minus 1, that will be plus 3. So I'll just write for you 1 plus 3 is equal to 4. So the 2 points of intersection we have found out, 4 comma 4 and minus 1 comma 4. So this is what you can tick, the option that can carry these two choices, I mean these two intersection points. Then that's what you're going to tick. Second, so again now you can pause the video and try this out. However, I'll have to do it for you guys. Let's see. Minus 2 is equal to x squared plus 2x plus 4. Rearrangement, x square plus 2x plus 4 plus 2 is equal to 0. X square plus 2x plus 6 is equal to 0. Now we know the product of the roots should be plus 6. So either two negative numbers can lead to plus 6 or two positive numbers can lead to plus 6. When two positive numbers will lead to plus 6, their addition would not be 2x. And when two negative numbers lead to plus 6 as a product, then two negative numbers would never add up to give you a positive number. Ideally, this cannot be done through the middle term split method. We will have to take help of the quadratic equation. So x is equal to minus b plus minus under root of b square minus 4ac upon 2a. B minus b is minus 2 plus minus under root of 2 square is 4 and minus 4 times 1, which is a is the coefficient of x square if you know, and then c is the constant 6 divided by 2 times a. 2 times a means 1. So minus 2 plus minus under root of 4 minus 24 upon 2, that will be minus 2 plus minus under root of minus 20 upon 2. So as you can see, we have got this under root of negative 20, which makes us realize that there is no x-intercept, no real x-intercept that's gonna uh, you know cut the parabola, or we are not going to get the intersection of a line and a parabola. The line doesn't cut this parabola at a point, so we are not going to have um, any choice with it, and probably this line doesn't cut the parabola anyway. So this is this sort of a relation. Correct. Now next, solve the following equations simultaneously. Simultaneously we have to solve these two equations. So again we have got equal y's on the left hand side, that is both have got same left hand sides, so we will equate the right hand sides. X square is equal to 2x, solve it. 2x minus x square is equal to 0, so x common. 2 minus x is equal to 0, so either x is equal to 0 or x is equals to, or 2 minus x is equal to 0, so x is equal to 2. These are the 2 points. So the y values will be y is equal to x square, which is 4, or 0. So the points will be 0. When you put x is equal to 0, you get y also 0, and when you get put x is equal to 2, you get y is equal to 4. 2 points, 2 points. Same with the next one. Pause the video, try this question by yourself. 3x is equal to, 3x plus 7 is equal to minus 4x square minus x plus 6. So rearrangement, I'll bring these on the left hand side to make the x square positive. So 3x plus 7 plus 4x plus x minus 6 is equal to 0. 4x square. So 3x plus x is 4x. How? So 4x square plus 4x plus 1 is equal to 0. We have got a whole square here and a whole square here. So it is 2x whole square and a 1 square. And in between we have got 2 times 2x times 1. Hence, it's a quadratic, like it's just 2x plus 1 ka whole square is equal to 0. So x would be equal to minus 1 by 2. So y would just be equal to minus 1 by 2 times 3 plus 7. So 7 minus 3 by 2. 14 minus 3 is 11 by 2. This is a point of intersection. Last one is this, I would leave on you, but I would solve a little bit. As you can see that this doesn't have a left hand side as y. So what I'll do, I'll rather plug in the y of x square plus 1 into the equation. So 2x minus 3 times y is x square plus 1 is equal to minus 4. So 2x minus 3x square minus 3 is equal to minus 4. So we have got negative 4 on the left hand side. Let's take it. 2x minus 3x square minus 3 plus 4 will be plus 1 is equal to 0. Change all the signs, multiply by negative 1 because we need to get rid of the negative over here. 3x square minus 2x minus 1, 3x square minus 2x minus 1 is equal to 0. So the product of the roots should be minus 3x square, and the addition should be minus 2x. So you can just put either you can put the quadratic formula, x is equal to minus b. So minus of minus 2 will be plus 2, plus minus under root of b square 4 minus 4ac. 4 times 3 is 12. 12 times minus 1 is plus 12 upon 2a 6. So 2 plus minus under root of 16 upon 6. 16 is plus minus 4. So we'll just have 4. 2 plus minus 4 upon 6. So it's either 6 upon 6, which is 1. It's either 1, or 2 minus 4 is minus 2. Minus 2 upon 6 is minus 1 upon 3. So you can plug this into the equation again. I don't have space, I'll have to work it over here in this box, guys, sorry for this. So yeah, so y is equal to 1 square, so 1 plus 1 is 2. So at x is equals to 1, we have got y is equal to 2, and at x is equal to minus 1 upon 3, y is equal to 1 upon 9 plus 1, that is 10 upon 9. Yeah, that's it. So we got 2 points. One is 1 comma 2, the other one is minus 1 comma 3 comma 10 over 9. Now simplify the following expressions. Well, we've got a negative power over here. You have to realize this, and a negative power here. Whenever you spot the negative power, your first point should be change their places. So 4n cube, this will go to the numerator, n to the power of 4 divided by, the numerator will come to the denominator, 8 m to the power of 5, which was already here, times m to the power of 2. Now you know that whenever in multiplication there are same bases, the power gets added. 4n to the power of 7 divided by 8m to the power of 7. 4 also will cancel, so it will be n to the power of 7 upon 2m to the power of 7. Next question. Here we spot a division sign. First and foremost, what would you do? Change it to the multiplication. So 2m to the power of 3 over r square n to the power of minus 4 to the whole power of 3 times 5m minus 2 n to the power of 3 upon r to the whole. Sorry guys, it has to be reciprocal. I'm sorry. So r over 5m minus 2 n to the power of 3 whole power of 2. Square will happen anyways, because ideally numerator and denominator both are squared. So now it looks finer. Again, now you got a negative power spotted. Change their places and also expand them out. So 2 to the power of m to the power of 3. 3, when inside of the bracket you're having a power of 3, and outside of the bracket you're having the power of 3. You can multiply the powers. It will be m to the power of 9 divided by r square. R square to the power of 3 will be r to the power of 6, and n to the power of minus 4 will go to the numerator. It will become n to the power of 4, and that to the power of 3 would be n to the power of 12 times r square. Denominator में you are having 5 square 25 times n cube, n to the power of 6, because we are having the outer power as 2, and then m to the power of minus 2 will go to the numerator. It will become m square, and then whole square will be m to the power of 4. Got it? What have I done? M square to the whole square. Correct. So here we have got the final thing. Now we'll just solve it out. When you have the same bases and same powers in division, you can cancel, and we are left with the 4 powers of r in the denominator. N to the power of 6, 6 remain on the top, m to the power of 4. So we have got 2 upon 25 in the numericals, and then in the power we have m to the power of 9, n to the power of 6, and m to the power of 4 upon r to the power of 4. It is still solvable. Same base in multiplication, powers will be added. 2 upon 25 m to the power of 13, n to the power of 6 upon r to the power of 4. This should be your final answer. Okay. Have we left the question? One of the questions. 1 second. This I solved. Then C. Yeah. Express in positive indices. Positive indices means you just have to get rid of the negative indices. How would you do so? You will just write 2b on the top. A, since it is negative power, it will move to the denominator. Times 3, again a to the power of 2, and b to the power of negative 3 will be b to the power of 3. Final answer will be 6. One of the b's get cancelled, and denominator a to the power of 3 times a to the power of 2 is a to the power of 5, b to the power of 2. That's your answer. Because these are the positive powers, you can leave the answer here. Next. Division spotted, reciprocal the right fraction. So a to the power of 2 to the whole power of 2. If you have to do it in some concise steps, you will have to follow this. So b to the power of 6 upon b to the power of minus 2 times minus 2 times 2 is 4, minus 4 times a to the power of, now first reciprocal this out, a square upon a b to the power of 4 whole power of negative 2, still it's negative 2. Why? Because we have first transitioned it to the multiplication. Now we will flip it again to get rid of the negative 2. That will be a to the power of 4 b to the power of 6 upon b to the power of minus 4 times a to the power of nothing, b to the power of 4 upon a square, now whole power is 2. Now expand it. So x to the power of 4 b to the power of 6 upon b to the power of negative 4 times a to the power of 2 b to the power of 8 upon a to the power of 4. A to the power of 4, a to the power of cancel, b to the power of 6, and now this is negative power, it will go on the top, so it will become b to the power of 6 times b to the power of 4 and times a to the power of 2 times b to the power of 8. So 6 plus 4 is 10 plus 8 is 18, a square times b to the power of 18. That should be the answer. You all also pause the video and do try this question again. Next we go on to simplifying the surds. Now 5 upon 25 is without any surd, so we can simplify this. 5 times 1, 5 times 5, and now we've got a surd on the top, so it can be written as 2 times 100. Why? Because I need to extract the maximum perfect square that I can extract, so that's why I've written it in the perfect square form. Now 10 is a perfect square of 100 is a perfect square of 10, so 10 comes out, 1 over 5 as it is, times 10 out, and in the inside we have got a root. So 5 still goes into 10 as 5 times 2. The final answer is 2 root 2. This will be present in the option choices that you have to mark. Next, 3 under root of, now 3 upon 14 cannot be solved. We have to write it as it is. 147 will be 7 times 21. 7 times 7 times 3. So we got a perfect square. 7 comes out to 3 upon 14 times 7. In the inside remains root 3. 7 can go in 14 two times. 3 over 2 root 3 is the correct answer. Next. Now we just have to add surds. Adding surds requires you to add only those type of surds where you have the like terms. Like terms are decided based on the under roots. So like terms are minus 4 root 10 and plus root 10, that will give you a minus 3 root 10. And then you have got a 2 root 2 minus 5 root 2, that is also going to give you minus 3 root 2. That's it. Then you've got a perfect square inside 3 times 7 minus 2. Now this is in the inside, we've got 144 times 2. Quite visible. 288 is 144 times 2. So perfect square extracted. Again, 144 is a perfect square of 12. 12 written as it is. 2 times under root of 9 times 2. So 144 perfect square of 12. So we can bring 12 out. 21 minus 2 times 12 root 2 minus 12 minus 2. 9 is a perfect square of 3. So 3 comes out, root 2. So this is 6 root 2 of negative. 21 minus 10 is 11. 11 minus 2 again is 9. So 21 minus 12 is 9. 9 minus 2 12 is 24 root 2. 24 root 2 and 6 root 2 is how much? 9 minus 30 root 2. This should be your answer. Or there is another way to write this answer, as if you can take 3 common and then you've got 3 minus 10 root 2. Whichever way you want to write, whichever way the answer are present over there. Correct, guys? So I believe there's nothing wrong in this question. Just cross-checking. 21 take away 12 is 9, and 24 root 2 of negative and 6 root 2 of negative would add up to 30 root 2. Yeah, probably there's nothing wrong. Next we have AB as root 7, 27, and root 25 is AC. This is hypotenuse, this is the perpendicular. This base we have to explore. So perpendicular square will be root 27 square plus x square, that leads to root 75 square. So 27 plus x square is equal to 75. 75 take away 27 is, so 75 take away 27 is equal to x square. You guys calculate what is 15 take away 7. It is probably 8. So 8, and then 6 take away 2 is 48, right? So x square is equal to root 48. 48 is 6, sorry, 6 8s are 48. So 8 and 16 times 3 also I can write as 48. Yes, so it will be 16 times 3 is 48 also. So I can write this as x is equal to under root of 16 times 3, which is 4 root 3. So we got the value of x as 4 root 3. That's it. Next, this is based on the similarity criteria, where we can see that these two lines are parallel, hence the corresponding angles are equal, and this angle is common. So by AAA, the small triangle is similar to the bigger triangle ADE. So we can also say that ABC is similar to ADE by the AAA criterion, correct? So now here we have to find the scale factor. Scale factor is new length upon old length. So new length was, new length is 9 plus 6 is 15 upon old length was just 6. This was extended to D. So we can just say that 3 times 5 is 15, 3 times 2 is 6. 2.5 will be the scale factor. Find the value of x. If you have to find the value of x, there are two ways. One of the ways is 6 over 9 is equal to 5 upon 6. Basic proportionality theorem it is called, that AB upon BD is equal to AC upon CE. There is another part of the same theorem which also states that 6 upon total 6 plus 9, which is 15, is equal to 5 upon 5 plus x. The either ways you're going to get the same answer, 3 times 2, 3 times 3. So 2x is equals to 15, x is equal to 15 upon 2, which is 7.5. Other way, 3 2s are 3 5s are 5 5s are 25 is equal to 10 plus 2x. 2x is equals to 25, take away 10 is 15, again same 7.5. So either ways you got the x value as 7.5. Okay, next, very important questions. Here you have to apply a property that states that the central angle is twice the angle inscribed by the same arc on any point of the circle. Correct. So this is the arc that you can see that I've marked with the red. This has created an angle of, or subtended an angle of 100 degree at the center, and this arc would extend an angle of x degrees on the any part of the circle. So that x would just be half of the central angle. So this will just be 50 degrees. Similarly, x over here is twice that of the inscribed angle at any point of the circle. So central angle is twice of it. So x is equal to twice of 40 degree. That will be 80 degree. Again over here, x is at any point on the circle and 76 is at the center. So x is just half of 76, which is 38 degrees. Similarly, here it is 240. So central angle is 240. X is equals to half of 240, which is 120 degrees. So you just had to have this one single property in mind for these questions. Next one. Another property that we are going to look at is tangent property. TA and TB are probably the tangents on this circle, and OA and OB are radius. Okay, so we should know that radius is always perpendicular to the tangent on the circle. This is a fact and property whose proof also we have done, but not here in this questionnaire uh, session. So here you can see that this angle is 220 degrees. This is the reflex angle 220 degrees. So you have to explore the O angle. So O angle will be 360, take away 220. How much is that? So if you take away 220, so that will be 120, I guess. Right? So now you can see that PA OB is a coordinator, right? So total angle sum is how much? 360 degrees, right? That means A plus 120 plus 90 plus 90 yields a 360 degree. 120, sorry, 180. 180 plus 120 is, one second, I think this is 140. Sorry, because if you will take away 220 from 360, it should be 140. Sorry. Yeah, so 180 plus 140 is, you can just do 180 plus 140, which is coming out to be 320 degrees. So A plus 320 degrees is equal to 360. So A will be 360, take away 320, which is 40 degrees. That's the answer. Next question. Here we have been given 125 degrees. One of the ways is that exterior angle is equal to the sum of opposite interior angles. Correct. So 125 should be equals to 40 plus x. So x is 125, take away 40. 5, 12, 12 take away 4 is 85 degrees. Am I right? So either you can do it like this, or the other way around is angle sum property. So I will write 65 here. Hello. So that will be 105. 105 plus 75. So 4. One second. 55 it should be, sorry. 55 and 125 will give you 180. So that will be linear pair. Okay. And then you have 40 plus 55 as 95. So 180 take away 95 is 85. Either way it is correct. So angle sum property states that 40 plus 55 plus x is equal to 180, and 95 plus x is equal to 180. So x is 180, take away 95, which is 85 degrees. Okay, this is how this question was to be approached. Next is another property. This is a semicircle property. Actually, this AOB is the diameter of this circle, and the diameter always subtends an angle of 90 degree on any point of the circle. So even if it would have been over here, it would have subtended an angle of 90 degrees only. Okay, so now look at this triangle AKB, and we have been given 65 degree as one of the measurements. The other measurement is 90 plus y is equal to 180 degrees. So 9 plus 6 is 15, 155. So y is equals to 180, take away 155. How much is that? 5 and 15, 16, 17, 25 degrees. Correct? That's it. So y is 25 degrees. If you have any problem, you can just let me know, or in the comment section below. I would retry to explain it there. Come to this hexagon. This is a equal hexagon, means a regular hexagon, and we can see that there are 3, 1, 2, 3, 4 triangles possible. So 4 times 180 will be the sum of these angles. 4 times 180 is 720 degrees, sum of all the angles. So there are 6 y's which add up to 720 degrees. This is how you actually calculate the sum of interior angles. You divide the hexagon or any polygon into the number of triangles, and then times it by 180, because each triangle is of 180 degree measurement of angle sum. So that's why I have written 4 times 180 is 720. Now 6y is equal to 720, so y will be equal to 120 degrees. Because if you will divide 720 by 6, you will get 120. So each angle is 120 degrees. Again, similarity, scale factor. So we'll first find out this x. So 3 over 8 is equal to, 3 is the smaller triangles part and the bigger triangles part, AB will be 10 take away x. Okay, so 3 over 8 will be 10 take away x over 10, correct? So 30 is equal to 80 minus 8x. 8x is equal to 80 take away 30, 50 x 4, no, 2 4s are 2, 25s are 25 upon 4 is the value of x. So it can just be 4 5s are 20 and 4 6 are 24 actually, and 0.25. So yeah, x is equal to 6.25, and scale factor is just 3 over 8, so you can easily find out the scale factor. Last but not least, this question again very important. You can see that O is the center, and hence OB and OC are radius. Correct. O is the center and OB and OC are the radius. When OB and OC are the radius, that means they are equal. That means this is an isosceles triangle. One of the side is 36, the other side has to be 36 degrees. So your angle BOC would just be 180 take away 72 degrees, which would just be 108 degrees. If you got X as, or angle BOC as 108 degrees, which is central angle. If this is a central angle and this is what you've got, then your angle B degrees would be 108 divided by 2, which is 54 degrees. That's it, guys. This was the last sheet, and I think you got the explanation well. And here I would just like to write the answer. B is equal to 54 degrees.